Boiling points. So I'll provide a quick introduction to the boiling point experiment. Like melting points, boiling points can be used as a measure of identification for an unknown compound. It's also very useful when we come to the distillation experiment to know where the boiling point of a molecule happens to be. Now, unlike melting points, boiling points are not used so much for purity. Yes, if there is an impurity present in the compound, we will get boiling point elevation. So the boiling point will be higher than that of the pure compound. This is a colligative property that you would have learned about in general chemistry. But it's not nearly as useful a measure of purity as the melting point is. And so we use other techniques to assess purity for liquids. Now, what we'll do in this experiment is we will measure the boiling point for a known compound, isopropanol. And whenever we do this, we want to measure the boiling point multiple times and then average those measurements and calculate a percent error relative to a known literature value. So percent error I can calculate in the following way after I've averaged my values. So percent error. So percent error here is the absolute value of the experimental value minus the accepted or literature value divided by the accepted value. And then that quantity multiplied by 100%. That will be my percent error here. And so we will first measure the boiling point 3 times for isopropanol, and then compare our experimental measurements to the literature value and calculate percent error. And then we will measure the boiling point for an unknown compound. So we'll again measure it 3 times, average those measurements to give us an average boiling point, and then compare that boiling point to the boiling points of several possible compounds in order to assign the identity of the unknown compound. So let's go get our stuff and get into lab. So let's talk about what you'll need for the boiling point experiment. First, you'll need your known compound, which is isopropanol, or isopropyl alcohol, or 2-propanol. You'll need capillary tubes, just like we used in the melting point experiment. We're going to use them slightly differently here. You will need a thermometer, a test tube, and a small rubber band that you can use to rubber band the thermometer to the test tube. I'll explain that in a moment. You also need a particular piece of rubber septum here that can open. This is used as a thermometer clamp. You don't want to clamp directly onto a thermometer. You'd be very likely to break it. But this rubber piece can clamp onto the thermometer. You can put the thermometer through there, and then you can clamp onto the rubber piece without any fear of breaking the thermometer. And then you'll need an unknown for the second part of the experiment. We've got unknown 1. And we've got a hot plate here with a water bath, which we can raise the temperature simply by turning on the hot plate. And we've got a clamp that we'll use here to clamp the thermometer. So those are the pieces. How do we go about setting up the experiment? Well, the first thing we want to do is we want to rubber band your test tube to the thermometer itself. Now, you want the bottom of the thermometer to be level with the bottom of the test tube. So let's see if I can show you here. You want those two to be level. Now, how do you do that? You want to rubber band them together with a small rubber band, but you don't want to just hold them and try to do that. You're likely to break the thermometer. The best way to do this is to first put the rubber band onto the test tube. I've got the rubber band onto the test tube, and then slide the thermometer next to it and simply stretch the rubber band over the thermometer. Now, of course, they're not even, so now you just have to kind of spread it up, adjust the thermometer so that they're about even. And now you should have, you also want to just adjust it so that you can see, spin the thermometer so that you can see the markings. Then what we'll do is you'll want to take this and take the rubber piece. You can put the thermometer through that, generally on the inner hole here. And now you'll want to adjust this to a point where it's convenient to then clamp onto the rubber piece right here so that it will hold the thermometer and test tube suspended in the water bath. And so I will set that up and then we'll continue from there. So here we have the thermometer and test tube rubber banded together and clamped into the water bath. Here, and at this point, we can add our known compound. So let's zoom in on this for a moment. So here, we will add now our isopropyl alcohol. A small amount. We don't need an excessive amount, but we want to have enough to be able to work with. So almost certainly more than is necessary here, but it is better to be on the safe side. And then from here, we will add our capillary tube. And we want to take our capillary tube and put it in upside down. So we want the open end pointing downwards into the liquid. So now you can see that capillary tube. You can see a couple bubbles escaping from the bottom of that capillary tube right there. And we are, at this point, ready to begin the experiment by turning on the hot plate, heating until we obtain a steady stream of bubbles occurring from the end of the capillary tube. And then we will turn off the temperature and measure the temperature at which liquid first enters the capillary. So the stream of bubbles will stop, and then we will get we will have liquid enter into the capillary, and at that point, that we will take to be our boiling point value. you.